understandable because they came from a very, very low level. So that's why, look, 20 years ago, we were very, very low. And of course, very easy achieving such growth rates over the years compared to the high level from which we ever start. Plus, we had a huge market internally, naturally. So we have more possibilities and more chances of changing that. Some concerns remain about the growth rate, since that includes also public spending on infrastructure. But the infrastructure, as I hear, China is now getting close to being fully developed. You cannot build airport after airport and high-speed train after high-speed train to all the remote places where they don't need it in the end. That requires a bit maintenance in the end as well. It's not only about establishing the stuff, but keeping it running. Just speaking from the German experience, or look, the US similar. The infrastructure is very weak now due to lacking maintenance of the last years.
Yeah. I don't know. China maybe disproved this Zedong's Li implementation, and maybe they will just go through 3 stages in 1 generation. God knows. Or maybe country is so big that you cannot treat it as one economy. So it's.
Doug, I have a question. You know, Russia developed your own vaccine for COVID-19, and is it true that the vaccine will be produced in Korea?
I read this news today. It says so. It was the Moscow Times announcing. Let me have a look. I should have the article here.
It's covered in Russian news media already.
It is.
Why it is produced in Korea? I mean, is it production so complex, or what's the point?
Korea has a very good capacity for those pharmaceutical production, vaccine production.
But what is production? I mean, I thought that the production is trivial once you have the kind of, you know, the formula. I thought that this is production is no problem, but.
No, this is the typical problem that you have. You have the formula, and you have maybe some milliliters or something like that at the lab level, and suddenly you expand from milliliters to liters, so it's a bigger amount, and you need to maintain the quality of production. So when you do one small production, one small unit in the lab, you have everything under control. But in the mass production, it's much more complex. But you keep everything step by step. So it's not such an easy undertaking. And I believe still this is the biggest issue when you go for the innovation process. The biggest issue is not about engineering design. The biggest issue is converting from the prototype to mass production. Still keeping quality level, keeping the budgets and all these related issues. That is usually the big challenge. A bigger challenge, which receives less attention, like the interface engineering to operations maintenance.
Yeah, it's true. Reuters report that they're starting next month 150 million doses in South Korean firm. What's the name? GL Rafa.
Yeah. It's covered in Korean news media too. Yeah, but you know the producing vaccine is like production semiconductor. It's a clean room technology, similar to Samsung semiconductor production, in a sense.
Yeah. The clean room technology is not an easy thing. At least I believe. And second, I would assume as well, maybe for Korea is also a market for the Russian vaccine. Could be the case that we saw the Sputnik 5, yeah. Or also the Korean market. I don't know. But there seems to be a big problem with the Pfizer vaccine, the Pfizer one which was announced this week, which was the RNA method. It requires cooling to 70 degrees below zero. So when you have a logistics event, which you need to cover to deliver that stuff. So this is pretty much a challenge. In any case, at least it gives us some hope that we will get rid of this usual burden which we face here, getting back a little bit of more of our freedom.
But what about the clinical trials of the rational vaccine? Because the claim is that it hasn't been tested widely. It's on news is on 20 people, something like that, kind of. So
phase 3 of the trials is still undergoing. It's not finished yet.
Okay.
So there was a huge misunderstanding. There was an announcement in summer which say the vaccine is registered in Russia, but registration in Russia means it's eligible for phase 3. So we finished phase 2 and we started phase 3 in summertime. But phase 3 takes a longer time. The announcements here, the statements here are saying probably by next year, March, April, we will have the final results also for watching after you had a second dose. So it will take twice or 2 times vaccination. So you might see it then, not much earlier. And the problem also for all the other vaccines, they undergo the application to FDA and the European agency, but still nobody can really reliably predict does it really work and how long does it make you immune against getting the virus. That is something we might know in 3 to 4 years time. We cannot speed up nature, fortunately, not yet.
Yeah. Okay. Are we alone now here, or no? We have 17 people. Okay.
Yes. So okay, I think we can start. Also, Nick will join us in a few minutes, hopefully. So it's 7 o'clock in the morning for Nick. We should give a warm welcome to him as soon as he gets up. He comes back from swimming in the ocean at Ipanema. I'm simply jealous. But what we have here in addition, we have only a limited number of people in the Zoom session. We have the parallel session via YouTube. That is for the reason, just for security. Zoom, you never know. There might be some people logging in and doing some unpleasant things. That's why I was informed the invitation for the Zoom session was limited to a pre-selected choice of people, only those who are capable, competent, and who we trust. That is also, but I don't know how many are watching us now at YouTube. At YouTube, we have 2 different channels, one in Russian, one in English language. And if you want to listen now at our Zoom session in Russian, you can switch the language here. We have in the bottom, you see there's a button called interpretation. You can choose the language. If you don't click the bottom, we keep with English, but you can also choose the Russian version. So for those who enjoy listening to the Russian version, take the Russian. I would suggest we start right away now. And for those in the audience who find something to ask the presenters, please type your question, your comments and remarks right away in the chat function so that we can raise these issues immediately after the presentation is closed. We will have 4 speeches today. In the first session and the second session, we will have another 3 speeches. So we will start with Professor John Dong-Lee, who is with the old national. Oh, sorry. We start with Coyne. So we will start with Professor Coyne Lee, who is with Seoul National University, the former president of Schumpeter Society, and did a lot of work about the technology upgrading. So I would call him here kind of the godfather for upgrading. And Coyne will talk to us about the economics of leapfrogging, which is much related and much behind here. So I'm looking forward to a nice, interesting speech as we know it from you. I give the floor to you, Coy.
Oh. So can I, let me try to share my slide. Okay.
Yes.
Is it shared?
It says you started sharing, but it doesn't show the presentation yet.
Why it doesn't work?
This technology. It requires upgrading, I believe.
Keon, you need first to open the presentation on your computer and then share screen.
Okay, let me see.
Just open it from your folder and then go back to Zoom.
Is it okay now?
Yes.
Yeah.
Okay. So you see my screen?
Yes.
PowerPoint?
Yes.
Okay. Thank you. As you introduced, my topic is about leapfrogging, I think, which is good fit for the theme of this session, which is about emerging paradigm. Okay. So the term leapfrogging came from article by Perez and Sote when they talk about leapfrogging and windows opportunity, which is a Schumpeterian concept. And they said that when there is change in technical paradigm, that's the good time for try leapfrogging, using that time as a window opportunity. So latecomers save too much investment into old paradigm, but jump into new paradigm, and thereby leapfrog, so that they can be a leader in new era. For example, digital paradigm was a Windows opportunity for Korean company like Samsung to move ahead about Sony from Japan. Okay, so in a way, we can define leapfrogging as latecomers doing something new ahead of foreigners, thereby leap over the incumbent. So this shows the idea of, Ha-Jun Chang said that ladder is often kicked away, but I would say we don't need a ladder because we can fly a balloon. Flying balloon is leapfrogging. Okay, so even if ladder is kicked away, we can try leapfrogging. Okay. And why we need leapfrogging? Because as you get close frontier, it is getting more difficult to expect technology transfer from incumbent. Okay, so leapfrogging is a way to overcome IPR, intellectual property right barriers. You don't need to rely on IPR held by incumbent. And during paradigm transition period, IPR tended to remain reside in public domain, such as academia. Okay, so there is no dominant IPR holders. Okay. Also, leapfrogging is a way to avoid direct competition with the incumbent because latecomer trying new market ahead of incumbent. And this graph showed the idea of leapfrogging. Horizontally, we have a period. Vertical, we have a productivity. There are 3 generation technology, generation 1, 2, 3. If you are trying to enter this industry, you can skip generation 1 and 2, but jump into generation 3. Okay, So if you follow the old generation, that's the best following. But you can skip old technology, go into most up-to-date technology, same as incumbent, or you can pick up emerging technology ahead of incumbent. Sounds good. The risk is that often emerging technology is not that stabilized, so you might end up productivity lower than incumbent. So you might make losses. But if you endure, if you survive this loss-making period, you'll get the market eventually because you'll achieve higher productivity than incumbent. So that shows a risk and potential leapfrogging, importance how to manage earlier time entry risk. Okay. And we can compare this leapfrogging with the similar concept called long jump proposed by Hidalgo. They say that latecomer should make a jump to product space with producing more sophisticated technologies. But that's the intersectoral leapfrogging, which is more risky. But intrasectoral leapfrogging, which is you skip some generation technology, move into emerging generation. So that's less risky than intersectoral leapfrogging. But you need to have some sector-specific capabilities. It's like a wing. Without wing, you cannot fly. You might fall through the windows. Okay. But this big literature on product space has less concern for entry barriers. They don't talk about entry barriers, assuming that all space is available for latecomers, but that's not true. There's entry barriers. So leapfrogging is a way to overcome those entry barriers. Okay? But as I say, you need to take care of two risks. First, risk of making right choices among alternative technology. Second, sometimes there is no market if you enter too early. Okay, so that's why to overcome this risk, sometimes industrial polish or big venture capital is needed. Okay? Or patient capital mentioned by Matsukato. Okay? But next question, when is good time to try leapfrogging? Answer is not every day, but on good weather. Because you cannot fly balloon every day, you have to wait for good weather. In this case, good weather is a time for paradigm change, where new windows are emerging. Okay, so leapfrogging has higher chance when tried during the paradigm shifting period. Okay. And why we have a higher chance? Because everybody is beginner starting at the same start line. Further, some incumbent fall into incumbent trap. Means maintaining current technology without bothering to switch to new technology, given their superiority with the existing technologies. Now, another thing is that which sector is more prone to leapfrogging? I would say there's short cycle technology, because short cycle means more frequent arrival of new technology. Now, this graph shows that BRICS country cycle time average using US patent, and it normalized. So less than 1 means more shorter cycle. This is China is shortest cycle. And after that, China is Russia is getting short and short, getting close to China's average. And South Africa, Brazil is too long, a long cycle. It's not good for latecomers to try long cycle. Long cycle means high entry barriers, very difficult to make quick success. So in that sense, Russia is showing some very promising sign that they are getting into short cycle technology, as in the past, Korea, or current recent past of China. Okay, so Russia is well positioned to try leapfrogging in this sense. In my other collective work with Frank Mallarba, we published the special use and research policy about catch-up cycle, which is about leadership change in each several sectors. And leapfrogging has a key role in bringing change of leadership. Okay. So we discussed several sectors: cell phone, memory, camera, mid-sized jet, steel, and wine. In many cases of leaders changing from some incumbent company, country, or latecomer countries, or latecomer firms. Okay. In many cases, there is an element of leapfrogging involved. responsible for bringing leadership changes. Okay. So we can see several types of leapfrogging. First, some latecomers skip some vintage of old capital and jump into same generation technology as incumbent. That's case memory chips or steel in Korea to rise in steel industries. More proper leapfrogging is that latecomers trying more radical endogenous innovation by themselves. That's case of cell phone Nokia against incumbent Motorola, or mirrorless camera in 2000, and mid-size jet in Canada, Brazil was trying this strategy. More ambitious leapfrogging is that less ambitious one is that you adopt and you try follow-on innovation. So in other words, you don't have to first move in generating innovation, but you are forced to adopt that generation technology, but introduce further improvement to reduce cost or improve productivity. That's case of steel in Japan, adopted the BOF method from Austria, but further improved it to take over market from US steel. Okay, so these are the several types of leapfrogging, the variation of leapfrogging. So you can see this table shows several variation of leapfrogging. In terms of path or trajectory of incumbent, we don't have to go through same trajectory incumbent, but you can skip some stages. You can create new paths rather than fast following. Also, in terms of the two variations of path creating, one is that you follow innovation based on adoption of new technology, or you can bring in newly radical innovation. Also, we can talk about intersectoral versus intrasectoral leapfrogging. Okay, that's which I mentioned before in comparison with the concept of a long jump. Okay. We can also talk about leapfrogging in terms of different types of companies, startup versus incumbent. Among incumbent, we can see there can be leaders, followers, laggard. So startups, they're often trying path creating, more radical leapfrogging, or follow innovation or business model innovation. Okay, but if you are follow with some experiences, you might be trying stage skipping leapfrogging. Okay, by doing public-private joint R&D or some government support. If you're laggard, you should first build capabilities by taking detours rather than trying leapfrogging. And so you can try upgrade by moving into high-end segment in the same sectors. Okay, so we can talk about two types of latecomers advantages. Traditional one means that latecomers can install more without paying for R&D costs. But now current context, latecomer advantage 2.0 might be you can try new business model innovation, adopting first industrial technology without paying for R&D. You can just try business model innovation or some follow-on innovation, okay, without paying for full cost of hardcore innovations. Okay. That's what happening in China. One example is the Indonesian company startups called ISSEK. They're using IoT technology for fish farming. In fish farming, most tricky method how to feed fish efficiently. Sometimes you feed too much, sometimes you feed too little. But using IoT technology, you can optimize the feeding amount and time. So this is a very successful startup, raised huge amount of money. One of the most successful startups become a unicorn in South Asian country. This is combination of new technology with resource-based industries. And also we can talk about two different aspects of incumbent trap. Okay, we used to say that incumbent trap happening more in advanced or incumbent countries vis-a-vis emerging countries. But in terms of company types, incumbent often fall into incumbent trap, whereas startups more light, not to fall in trap, trying something new. But it's good to have a better horizontal infrastructure which is including new digital infrastructure such as public cloud, big data, online, and so on. Okay? So we are now seeing another paradigm shift in terms of new energy revolution or Industry 4.0, which is fusion of several different technologies. So it's good time to try leapfrogging. It's happening in many countries, China, Brazil, or even Africa. Okay. In terms of sustainable development, we can also talk about leapfrogging using this Kuznets curve, environmental Kuznets curve. This is per capita income, this damage to environment. So ABCD is a path gone by incumbent. If latecomers going through the same path, huge damage to environment. So you can skip C by going through from B to directly D. This is another leapfrogging in terms of sustainable development ideas. So broadly, in my recent book, I'm suggesting comprehensive theory catch-up. Okay, so we are facing capability failures or main transition failures, or also IPR barriers. So we can try detours or leapfrogging. Detour means like from imitation to innovation, short cycle first, long cycle later, building domestic value chain, then to global value chain. And leapfrog, after you build capability by trying detours, you can try leapfrogging based on your built-up capabilities. Okay. So we have 3 catch-up paradoxes. First, to be different, you got to be similar in terms of market shares, performance. You got to be different. You should try innovation. Sometimes detour might be faster than thread load. Highway is jammed, traffic, too many similar copy. So that's why you take detours, and you can avoid traffic jam, reach the goal faster than those guys stuck in the highway. And you might fly out of windows if you have a strong wing, otherwise you fall through the windows. These are the catch paradoxes discussed in my book. Okay, thank you. Spasiba. Okay.
Switch on. Thank you very much, Coin. I would assume that some questions arise from the audience. I still have one question here. Leapfrogging is a good idea, but isn't it a one-time event? Isn't it challenge? How do you keep momentum? But the development continues, and you're not having only a one-time event, which helps you jumping up, improving a lot. But what if you don't keep the momentum? What if the initiative just drops down? Wouldn't it be more devastating?
I didn't hear clearly, but you're saying that how can we sustain leapfrogging not just one time, but
it matters one time. Yes, it matters one time, and you have an event which is like the course, which helps you to leapfrog to another level. But how do you keep the momentum that you're not stepping back, falling back to a previous level?
That's interesting question. Yeah. So we might want to say that you should have several complementary capabilities, not just technological, but also non-technological, or even so in SSA framework, sectoral system framework, there is a technology block, but there is a block of market, block of actors involving a lot of government and broad institution, including financial market, IPR, and so on. So maybe we to say those broad blocks or institutional factors might be important element which might sustain the initial leapfrogging success into a longer period, I guess. Yeah. Although I talk about only narrow dimension, technological dimensions, we can extend this question to include other dimensions.
Yeah.
Yeah.
Yeah. Quite a complex thing. not easy. So I don't see any other comments or questions here in the chat. If that's the case, let's continue with this time, right? Professor John Dong-Lee, who is also equally with Seoul National University, and he will talk a little bit about co-evolution of production and knowledge, which is very much an interesting topic. So looking forward to your presentation. JD, please, the floor is yours.
Okay, thank you for giving me a very good chance. Can you see the slide?
Yes.
Okay, good. I changed my presentation theme to talk about the co-evolution of the two spaces, one product space, the other technology space. First of all, I wanted to talk about the typical stylized pattern of diversification. The left-hand side, you can see the iPhone, and right-hand side, you can see the earphone made by Apple. Those two products are made by the same company, and then the right-hand side, the earphone is made after iPhone was made. So we can say that Apple diversified from phone to earphone. And is it possible for us to explain how Apple could do this kind of diversification? Maybe it's quite easy. Those two products are in the same electronics business. So if you can produce successfully iPhone, mobile phone, then you can do also you can do diversify into related products, quite easy. But how about this one? On the top left, you can see a film of Fuji of Japan. And this Fuji film has made film for the last more than maybe 6 or 7, 4 or 5 decades. And then now you can see the Lift cosmetic products produced by the same company, Fujifilm. Can you explain how Fujifilm diversified successfully from film making to cosmetic products? Those two products categorized into quite two distinctive group of categories. So it's quite difficult for us to explain how Fujifilm successfully diversified into seemingly unrelated products. And how about the next case? Samsung has been very well known to make a chip, but as you can see, Samsung also diversified into biosimilar sector, and then now it's now, as long as I know, second largest biosimilar product producer in the world. So it's quite difficult to explain this kind of a diversification also from semiconductor to bio, totally different products. We can see this kind of related diversification quite often, but also we can observe this kind of unrelated diversification more often than we expect. So today I wanted to talk about how can we explain this kind of unrelated diversification. This discussion may not also be confined to only products at the company level. The discussion can also be applied to country level. How one country, for example, one country resource rich such as natural gas and oil, and how one country with the abundant resource can successfully diversify into high-tech, unrelated categories of products. So industrial development has been known as the result of sophistication and diversification of products. It is not an automatic process and needs intentional policy support. In order to explain this kind of industrial process, industrial development process based on the diversification concept, the product space has been suggested by Hidalgo. This product space has been made based on the conditional probability of a co-occurrence among products in export data. And this is the product space made by our group following the methodology suggested by Hidalgo. Each dot represents each categories of products. And the light blue one, this one, shows the categories that may belong to machinery and transport equipment. And red one, manufacturing. And one of the main arguments of Hidalgo, who suggests this concept originally, each individual product or product category has a relationship among each other, and development process starts from peripheral and by diversification into core products one country develops. Stylized fact based on this product space analysis is that new products emerges in the neighborhood of existing products. So if you can do very well in producing oil, and then naturally we expect you can do also very well in natural gas, because those two products are categorized into energy products. And a higher economic performance is positively correlated with producing core products. And other important argument is that product diversification is a continuous and gradual process with high path dependence. Means if you locate one place and then next possible route or possible alternative for diversification is neighborhood, the products of locates in the neighborhood. So in the paper, Hidalgo told monkeys colonizing the forest, occupying more trees and moving especially into the more complex or fruitful ones by traversing the trees with the neighboring branches. So step by step, the advancement. However, jumps are more often than expected in the real world. Emergence of new products at the firm and the sector level, often from somewhere quite distant, not closely related to the existing product portfolio. Example we can find from the history of the Korean economic development. Emergence of the steel industry in Korea in the early 1970s, which had long been an agricultural agrarian economy. And as I already mentioned, biosimilar business in the pharmaceutical sector since the mid of 2000 by Samsung Electronics, which has been a giant in semiconductor business. So these are the examples of jumps. It's very hard to explain with the already explained product space concept, which argues that the emergence of new products from the neighborhood of existing products. And the other side of the coin, we can see traps in the real world. Traps defined as a failure to upgrade the products to failure to diversify in terms of sophistication and diversification, and locked in low value added function. So it's also very hard to explain based on the product concept. Are the jumps and traps are special case? From our observation, it's not a special case. We can see quite often the gradual development, gradual evolution, but also we can see jumps and traps. So we need a kind of conceptual framework to explain jumps and traps. So in order to explain the logic, I wanted to share some slide. This graph shows the schematic representation of the product space. Each dot from P1 to P10 shows different products, such as semiconductor, refrigerator, oil and gas, and so on. So if you the line connecting dots shows relationships, the relatedness. If your country are very good at P1 to produce P1 products, and then you wanted to produce P9, so-called core products, which has many good relations with other products. You are now in the peripheral, and then by developing the capability, you wanted to produce these core products, not peripheral. How this happens? Like this, starting from P1, and then next, the related diversification, and related diversification. This is the argument made by Hidalgo. But we can imagine another space, not product space, so-called technology space. Like products, technology also can be represented by space, because there are all different kinds of categories of knowledge. So T1 to T8 or 9, there are the different technology, for example, and then you are very good at in technology 9, T9, and then you want to acquire the technology or core technology, so-called T5. Core technology can be defined by the technology which has very good relationship with other products. So you have now the technology capability in a quite distant places from the core, and then you wanted to move to T5. How? Like this, with the related diversification in technology space, like this. So we have two spaces. What is the relationship between these two spaces? One product can be supported by multiple technology. Or we can say that one technology can support many different products. So we have two spaces. One is product space, another technology space. Those two space have some relationships. So for example, if product 6 is supported by technology 5 and technology 1, and technology 1 support product 6, 2, 8, and 9, and product 6 and product 9 locates a quite distant place in over the product space, quite distant, and actually do not have any relationships. But if we go one step deep down, then P6 is supported by T1, and T1 can support P9. So by producing P6, if you acquire T1, then you can have a chance to produce P9. So with this kind of relationship between product space and technology space, you can traverse from P6 to P9. It's a kind of jump. So this is these two cases are quite typical example of jump in product space through technology relatedness. So these two products has a common technology, so-called how can we organize more than 100 chemical compound within 10 micrometers thin kind of a thin plate. And this semiconductor chip production and biosimilar products production process have a common the technology in terms of quality control and operational management of clean room, for example. So we can observe those kind of relationship between product space and technology space over time. Stage 0, stage 1, and stage 2. Based on my observation, one country start from stage 0, nothing even in product space, and then the country start to produce P1, and then by producing P1, the country would have a chance to acquire the technology to support that product. And then based on that acquired technology, it can move into, it can actually jump. We can observe jump here into another distinct product categories. Here we can observe two jumps in the product space. The first jump, so-called jump without knowledge, emergence of various unrelated mid-tech products in the very low level of economic development. The example can be found for the case of Korea, starting the steel industry in the early 1970s. So the source of technology is just imported knowledge. Since we don't have any experience in terms of production and knowledge, so we are free to make a choice, very low lock-in. And for this case, the second one here, the second jump can be called jumps with knowledge. Emergence of selected unrelated high-tech products based on the accumulated experience. And it shows very high lock-in, not in terms of technology, but in terms of knowledge. Not in terms of production, but in terms of knowledge. So the good example can be found in studying bioproduct by Samsung in the mid of 2000. So I used all my time. So I went to, sorry.
This is you can extend a little bit. It's no problem. It's interesting.
Okay. If you give me a few more minutes.
Yeah.
And we can also find traps. So one country can maybe remain seated in low value added agriculture or energy businesses here, fail to move here. And even one country started to produce something, but it often fails to deep down the technology to acquire T1. And quite often, even though one country has some basic knowledge base, but it fails to diversify based on this acquired knowledge. So we can observe three traps. So the first trap in failing to challenge the production of core products by following the the comparative advantage arguments. So the second trap here, the second trap is in failing to deepen the core knowledge to support the core products by ignoring investment on knowledge accumulation. And third trap is in failing to diversify into new sector based on the core knowledge by lacking the entrepreneurial spirit. So I will just spend a couple of minutes to explain the current experience. This is the stylized pattern of the growth in terms of GDP per capita. And then Korea started the first stage jumps, this one. The first stage jumps in up to 1980s, from agriculture to heavy and chemical products from nothing. And from nothing means we did not have any problem out of a lock-in because we didn't have anything. Jumps into core product without knowledge. Here we can say comparative advantage defying process, not following process. And so as you can see, the 70s and 80s, the portfolio of, in terms of sectoral shipment, the share had changed dramatically. The second stage, deepening of knowledge, started from mid of 1980s up to 2000, from imported knowledge to accumulate experience and successful diversifying into neighboring products in on the product space. So in order to deepening the knowledge, the Korean economy increased R&D investment dramatically, and also we can find similar sharp increases of the effort to make a knowledge by the number of private sector R&D centers. This is the diagram we made to compare how one country can acquire the knowledge after production. The left-hand side shows the production advantage in product space, and right-hand side we can see the comparative advantage of technology. Left-hand side production and right-hand side technology. Each dot shows each categories. So in 1980, in electronics business, Korea shows this red dot, comparative advantage sectors, products. But in 1980s, we cannot see any comparative advantage in technology space. But after 5 years, we can see some emergence of knowledge, comparative advantage in technology space, like this, from 80s, 85, and 1990. So by starting, this pattern shows this one. By having, by accumulating production capability, but at the same time, Korea started to accumulate knowledge. And we are facing a third stage trap, I'm saying. So Korea needs to have more entrepreneurial spirits to go into unrelated diversification based on acquired knowledge. And so I'm asking to our audience in this Zoom, which traps is Russia experiencing? The first trap, or second trap, or third trap. So my main argument is that jumps and traps, rather than a smooth and gradual development, characterize the product diversification process. And co-evolutionary development process between production and knowledge can explain the jumps and traps of a diversification process. And every diversification is related diversification in terms of production or technology. Jumps in technology space can also be explained with the same logic. So this is the summary of my argument. Thank you.
Thank you very much. This is, I'm fascinated. I love it. I love it. It is what we see, I believe, in an aggregate level, in aggregate terms, we see it frequently with smart specialization, with core competences, but even at country level. This sounds very much like McKinsey in the 2000s when we came with core competence outsourcing and get rid of everything else. Now, what we lack here and focusing only on core competences is obviously a portfolio of competences. So the company, if you want to be sustainable in your business, you will diversify the activities. So just spreading the seeds around your core competences, your core business, because your core business dies faster than you would expect. Not yet died because we focused only on one core business and we didn't consider the full bunch, the full portfolio. And that's why I like to see it when exactly what you say. We have one product with multiple technologies and vice versa. So that goes even beyond the idea of technology platforms. They say, okay, we have the platform technology in many different businesses around Canon is the or projection and stuff like that. And we should convert that, integrate that exactly in the thinking also from policy side for upgrading countries. Because so far, economic development definitely goes for smart specialization, regional innovation strategies. Yes, I agree. Innovation strategy is a wonderful thing, but go away from focusing on core competences by means of probably building centers of excellence only. You need to have the seed around because what is excellent today is no guarantee for wealth tomorrow.
That's right. That's right.
So the priorities are changing. I think here we certainly can take a lot of ideas and concepts already from portfolio management, technology portfolio management at company level. Exactly what Samsung did. They looked for additional opportunities and they started investing, but not talking about it in the beginning. So they are grown, they grew and grew and grew. Everybody knows now Samsung. This is ICT. Probably nobody has an idea about Samsung and biotech, but that is the next business. So we see it in many successful cases. I think that this is wonderful. Slavo, you gave a nice comment here.
Oh no, please turn on your.
Yeah.
Oh, okay, good.
Yeah, this is really excellent presentation. I really enjoyed it, and it resonates very well with kind of what I'm also thinking. My problem is only that this is all based on the critical product space, but we live today in a world of global value chains. We live in a world of fragmentation. So how that story argument works in a world where technology capabilities are fragmenting, product are fragmented, and how do you reinterpret that?
Yeah, well, very interesting and important point. If I remember correctly, Pietro Belli, or no, who wrote about the paper of the cluster upgrading across GVC? Who participated two years ago in Sao Paulo? He showed 4 different patterns of upgrading across the global value chains, functional upgrade or I do not remember exactly, but I went to get those kind of borrow those kind of idea from the paper that the evolution on the product space can be described by the upgrading patterns over the global value chains. So my argument can also be applied to that case, how one company in one country can upgrade across the global value chain to a core functions. My argument tells us that not going through the production relationship, but going through kind of detour through knowledge space. Am I right? But very good points.
Yeah, we would need to think more about this, but
yeah.
You stimulate us all in this direction. So excellent, yeah.
And I wanted to utilize the expression Doug mentioned, business portfolio and core capability. Business portfolio or business competence can be represented on the product space, but core competence can be expressed on the technology space. So we need to analyze those two spaces altogether when we try to make an appropriate innovation strategy.
I believe here another competence comes into play. It's not so much about technology development, especially not in light of GVC. It is more about integration. So regardless where and which place of the world technology evolves, it doesn't really matter. You don't even need to understand it in full. What you need to have is a competence getting this stuff together into a system. So it's going to systems engineering. It's integrating different bits and pieces of different technologies to generate a new solution. It might be from the policy perspective a mistake always to think when we talk about the technology, we need to start developing everything here in one spot, everything. I believe if the focus is on integrating something, different technologies into a new solution, it is much more efficient and less cost intensive, but it requires different competences at the engineering side. So the technology is not coming and saying, okay, 1 + 1, and then you put it together like a puzzle. This is a bit more challenging, I believe.
Yeah, I just wanted to share with you some motivations of this paper. When I first invited to Moscow a couple of years ago, and then I tried to figure out what's the biggest challenge and headache of a Russian economy. And then a large number of articles told that Russia is very rich of natural resources and then very good at in producing and treatment of those kind of natural resources, but tried very hard, to diversify out of natural resources into another high-tech so-called fashionable business. So that was one of my motivation to start to think about this issue. So my hope is my idea or discussion can provide some insight to start those kind of discussions. How can we diversify smart way for the Russian economy?
I think what we can do here is, that's one for the Russian economy, but also for the academic community, we could probably replace smart specialization by smart diversification.
Yeah, but smart specialization, as long as I know, focuses more on the technology space.
Yeah. Yeah. So smart specialization certainly is one of the foundations, but going a bit more to diversification. I see Attila Havas has a question about what type of knowledge has Samsung relied on innovation management and marketing. Attila, you can also raise your voice, unmute yourself, and ask the question directly.
Okay. Yeah, for this matter, Gun Lee has a better knowledge than me, but he's out.
No, he's here.
He's here. Okay.
So just to clarify, thanks for these two excellent presentations. Young, you stressed that in that case, diversification was without knowledge, if I'm not mistaken. Sorry,
in the very first stage,
it was relying on knowledge, but in a completely different field of technology. So that's why I'm asking whether you refer to innovation management, marketing type of knowledge. What type of knowledge you refer?
Oh, so for example, to produce semiconductor industry world-class, you need world-class quality control technologies.
Yeah, this is what I assumed. Yeah.
Yeah, and then that technology
innovation management,
also,
marketing, quality control.
No, not that kind of soft things. Very hard things. Quality control in the production process, and so-called controlling the yield is very important for semiconductor, and also to make world-class bioproducts.
Okay,
not
you.
soft technology. Hard. There is a common hard technologies between those two sectors.
Thank you.
So thank you very much. I think we have a look how we can measure the upgrading. Slavo prepared a nice presentation. Professor Radosevic, if you see out, I will give the floor to you.
Thank you. Do you see my screen now?
Yes.
Yeah, okay. I apologize that I'm presenting something which many of you have heard well, a week ago, but the reason was simple, that here in this paper, I have at least something about Russia, and we have another paper where we applied the same approach, but to only EU economies. But I'll try to make it a bit more interesting. So the idea here in our paper is to apply technology upgrading approach to 16 economies in a period of 2000 to 2016, with the idea to apply a new framework which hopefully can give some light on the dimensions of technology upgrading which are not visible through standard type of conventional indicators which are R&D based. And technology upgrading is in our case a proxy for long-term potential rather than the kind of cannot be identified with the economic growth as such. It is the basis which shows what is the long-term potential of a country. What we have done as a new thing in this paper is try to connect this measure with the conventional measures of labor productivity and total factor productivity, simply as a way to establish the communication with the mainstream economies to see what is the value of that and try to link two perspectives. So we tried to develop that perspective, which we developed in a few papers before on a kind of conceptual and empirical basis. It is a perspective which is focused on middle income economies because we had these composite indicators around like global innovation index, various which kind of apply to all countries in the world, which are kind of then relevant for everybody and not relevant for anybody. The reason for that type of critique is that technologies and the upgrading is very country-specific processes dependent on the level of development, and it is a more differentiated process. It cannot be reduced on one variable, total factor productivity or R&D, and the current matrices do not take that into account. That there is simply the very much kind of putting the data in and whatever comes out without kind of more theoretical understanding or rigorous understanding of what is going on behind. It doesn't mean that we can solve that all, but at least we try to think more analytically about this. And very often matrices which are in use, they are irrelevant for middle-income countries because they do not reflect specificities of their technology upgrade. So the idea is to develop a framework which is more suitable for this group of countries. And it's almost like every group of countries should have its own metrics rather than putting it on one metrics and assuming that the drivers of the growth identical across the development process. And the work of my two colleagues before clearly showed that this is not the case. In this context, we also confine ourselves on technology upgrading, knowing that there are other factors which affect the overall outcome in terms of economic growth. This is the macroeconomic context, the institutional context, and we do not take that into account. We do not take that into account, not because it is not important, but because it is too important, basically, and would have to be rethought. How do you go about it? The whole issue of coevolution of technology and institutions then comes into play. But the basic idea is that the different levels of development and patterns of technology upgrading. And you can think about that along these lines, and very much of what Kun Lee is doing is leapfrogging, is moving from middle income to higher income. There is a shift, another one from imitative to technology diversification. So the Dong Lee also has this work from implementation capacity to design capacity. So this is all kind of, in terms of thinking, very compatible to that. That's why I kind of enjoy cooperation with them. In our approach, we take this kind of three-dimensional approach to technology upgrading, where we argue that the technology upgrading is reflecting the intensity of different types of upgrading, production upgrading, technology upgrading, R&D upgrading. Then you have technology upgrading as a structural process, kind of diversification occurs over development process. So that is a dimension which is inextricable of technology upgrading. And finally, all that takes place in international context. Catching up doesn't go without active use of foreign technologies. Therefore, technology transfer dimension is essential. That is we've done that kind of explained nicely in the paper in the context of literature review in the previous papers. Where is the main problem is always how do you convert it into kind of indicators, and that is something which we are all very critical, and it's very imperfect because technology is so multidimensional phenomenon, and reducing it on kind of 20, 30 indicators is always exercise with lots of problems. But this is a kind of attempt to try to do that, where we then have these three basic dimensions, and then we separate them on the categories which are reflection of what one can find from the literature, from our understanding of this, separating technology upgrading on three dimensions, interaction with global economy on also three dimensions, and the breadth of technology upgrading separating on important structural components. One can talk also about infrastructure upgrading, structural changes itself in terms of knowledge diversification, and also firm structure is important component of that. Again, I'm pointing that the problem is then when you want to translate it, because you have a specific number of countries for which there are not many indicators. That's why in our latest paper, we applied it to European Union countries, because there's much more indicators there and better availability. So this is simply conditioned by a very small sample of countries which we use in this paper. And these are the type of indicators for each of these type of capabilities. And these are the indicators which you use for the structural type, for technology, for the breadth of technology upgrading. And the third one, which is the most difficult, which is technology and knowledge exchange. Now with the database on global value chains, on trade in value added, that is possible to expand. But again, the duration, the length of the series, the coverage, everything is very imperfect. And we look at in initial stages around 150 indicators, and then you end up with very little. And on that basis, we kind of generate this index of technology upgrading, which is the consisting of the index of intensity of upgrading, which is this component, and the second component. And the third component, basically, which is this index, does not form part of the index. Why? Because whenever you look at this relationship, you see that this is a kind of dimension which has its own logic, and it plays more like a moderating role. In a sense, it shows that the intensity of involvement of country in the knowledge exchange doesn't correlate with the technology effort that is taking place within the country. And this is something which basically from the development economics doesn't surprise you, because the potential of technology transfer very often will not be exploited. Today we have a phenomenon of assembly economies, which basically are very active on this side, but that kind of close integration into global value chain does not lead to technology upgrading within the country. So we try to do first empirical exercise, which is the exploring this type of concept on the 16 countries where we take BRIC economies, China, India, South Africa, due to their global importance. Then we take Central East European economies because we're interested in that, in kind of taking all the different models from Hungary, like assembly economy, to Russia. Then we have Brazil, Argentina, and then we have South Korea, which is a paragon, obviously, of catching up. Israel is a model of that for many countries, and so on. Now we are doing the extension of that exercise where we have 78 countries, and you know, the results are basically broadly along the lines of this exercise. So we generate this composite index, and there's nothing exciting there. It's a conventional thing where you standardize the indicators and you put them on the same scale, which enables you then to construct this index of technology upgrading. And this is when you relate it to your GDP per capita. And where you see here that there is a kind of broad correlation, but also differences on the high income level, which is actually what you would expect, because our metrics is trying to capture middle income economies or high middle income, however you want to classify them, catching up economies. And this is what kind of is reflected when the countries goes into higher stages. Then obviously you would need more frontier technology kind of metrics. So, but it just shows, the idea is to show that there is some kind of relationship. Then when you look at the relationship between the scale, and this is the period of 14 years between the scale or intensity of technology effort and this breadth of technology effort, then you see that there are much bigger differences in terms of scale, in terms of intensity, and economies are much more similar in terms of structure, which means that on a nominally similar structure, you get very different patterns or the intensities of technology upgrading. And this is quite important stylized fact which comes. Then there is no correlation between the index of technology upgrading and the intensity of technology and knowledge exchange. Here we have only one assembly economy, Hungary, but if we were putting here countries like Malaysia or a variety of others, this would go completely in a kind of shapeless direction. And then there are big, greater differences in the changes of intensity. So this is the change in this 14 years period, and it shows you which are the countries which are catching up in terms of index, and surprise, surprise, you know, China is on the top there, and then Korea down, and in terms of breadth, you have another range of countries, but again, greater differences are in terms of changes in intensity than in terms of structural changes, which is a kind of, again, point that countries have a certain pace of structural change, but what they do based on that structure is very much then different from country to country. Again, when you look at the correlation over time, changes in technology upgrading intensity and the changes in the involvement in a global economy, you see that there is no kind of relationship. It's almost like a negative relationship. And in our sample with 72 countries, this becomes even more pronounced. Now, I said that we have included there also relationship with the conventional measures with the total factor productivity. And when you take total factor productivity, And when you take then this here on horizontal axis, you have changes in index in terms of total factor productivity. On vertical, you have changes in, on horizontal, you have changes in technology upgrading. On vertical, you have changes in technology in total factor productivity. You see that on the top, you have China and Korea, which are growing primarily in terms of technology upgrading. Then you have a kind of another outlier here, Belarus, which is growing in terms of total factor productivity, but kind of not differentiated in terms of the index. And then you have a Hungary, which is falling behind in a sense in terms of both total factor productivity and technology upgrading. And then you have most of the countries are kind of in between there. So it shows kind of when we use or economists use specific indicators, how much they are revealing or how much they are hiding, kind of. So that is the lesson here. The same is an interesting picture emerges when you take labor productivity. So here on horizontal axis, we have changes in the technology upgrading index. On vertical, we have changes in labor productivity. And here we have a kind of, again, on the top, we have China, which is growing both in terms of labor productivity and technology upgrading index. Then we have Korea, which is growing in terms of technology upgrading, but not in terms of labor productivity. And then we have countries like India, Belarus, Romania, where they're growing in terms of labor productivity, but not in terms of technology upgrading. You know, this shows then that we want to explore that relationship, and we do that on a very small econometric exercise where we take as dependent variable labor productivity and total factor productivity. So it's a very small panel, which we are expanding now. And the result is that the index of technology upgrading explains both growth of total factor productivity and growth of labor productivity. So we kind of try to establish the kind of link with the mainstream measures. But the point is that this index of technology and knowledge exchange is never explanatory element of growth, neither of total factor productivity nor of labor productivity, which is in a sense, again, confirms the intuition for development economics that if imported knowledge is not absorbed, is not complemented by your own technology efforts, there will be no improvements. Second important finding is that the total factor productivity is mainly explained by the scale intensity of technology upgrading, which in a sense makes sense in the context of emerging economies, middle income economies, and it is particularly explained by the subcomponent of production capability, which is kind of anyhow the major focus of technology effort on these economies, which is the working efficiently on a given technology. Then labor productivity is driven by the index of breadth of scope of structural change in the economy, in particular by the sub-index of broadly defined structural change in firm organizational structure, kind of in that place, which means that this labor productivity is very much driven to the structural changes in the economy or to the structural features of the economy, which is a kind of maybe makes sense, you know, because there are some sectors where labor productivity is inherently higher than in the others. So the point here is that which tries to show that there is a link with the mainstream measures, but the advantage on our side is that we can show then what is behind total factor productivity, what is behind labor productivity. And if you use these measures kind of blindly, then actually you don't understand what is behind unless you don't complement it with this type of measures. So that is the main value of that. In overall, I had to, you know, summarize a lot of results and couldn't say everything, but the results show that countries follow their own paths of technology upgrading, and there are very different patterns, and intentionally it's very good to do it on a small number of countries. Korea and China are the only economies which have improved on all three subcomponents of this index, while Brazil is the only economy that has fallen behind on all three components. In between these two extremes, kind of Korea, China, and Brazil, we find a variety of country-specific patterns, and that's where Russia is, kind of, is not exciting pattern, so to say. And I'm sure Vitaly will show us later on why it is the case of what is behind. Then our econometric exercise shows that the index of technology upgrading can significantly contribute to explain the both total factor productivity and labor productivity. Index of technology exchange does not contributes to explaining any of these two, because of this feature that the technology transfer can operate as a substitute or as a complement, so you don't get kind of coherent relationship. And it also confirms this fact that openness by itself is not the kind of magic bullet unless it is not complemented by technology effort. In terms of policy, result would suggest that you have to go beyond R&D driven growth. So it's kind of going in terms of matrices to matrices which are relevant for the technology effort in your economy. And very often we have kind of this idea, you know, that the policymakers will pick up the metrics which is the dominant, not the metrics which is the relevant for them in terms of country specificity. Then technology upgrading is really linked to structural transformation. And there is the issue of coordination failure, the biggest issue. And this is clearly also shown through the results in our case, and explains why these coordination failures are actually more pervasive, because they're systemic. And the technology exchange is not enough for technology upgrading unless it is not complemented, which means the technology upgrading is a coordination process which requires all three components, and they are all institutional and policy spaces, which means that the coordination among these three components is essential. Very often, you know, innovation policy is just what you do on your R&D side, forget what you are doing on your technology transfer side. Of course, there are limitations, choice of indicators. I think, yeah.
How to say? Yes, it's especially all the the number of front
Important, but one, because what you are usually left with is the, let's call it, general level of human capital. You know, use indicators like school enrollment, even average years of schooling. Of course, there are some recent kind of output indicators like qualitative assessment of the quality of math and science education. But technology upgrading is always, well, it's technology specific. So unless this, it is the institutional problems, whether the general human capital then becomes a kind of technology specific human capital. That depends on the enterprise context, depends on the really technology effort within the companies where these generic human capital becomes technology specific. And the issue is, how can we capture that? And we don't have indicators which would be kind of more differentiated at the same time comparable across countries. So this is the weakest and link, and that's why we have these inconclusive results even in the growth literature about the role of human capital. So we are basically sharing these imperfections of our glasses and lenses. Yeah. So
If we find a solution, it would give us a Nobel Prize probably, but being recognized only in 50 years' time, something like that.
I have a question. Yeah, can I ask?
Yeah.
I think it's very. I will not realize that is you put several very interesting and making sense findings, such as the openness are not important unless accompanied by certain other conditions. But my question is that the original question is about the middle income trap. So among those three components, which component are most responsible for the middle income trap situation, or do you have any explanation based on your theory how to explain middle income trap situation?
We have in the previous paper we explicitly refer to this middle income trap idea, because we compare these indicators with countries with different levels of income, and then we try to see associations there. In our case, the crucial variable of kind of which is explaining this middle income trap is this intensity of technology upgrading, because we show in the previous paper that in terms of structural features, middle income economies actually should be much better than they are. So in a sense, given their structural features, they're underperforming. So that is the crucial. The same as kind of in case of assembly economies, given how they're integrated, they should be doing much better. In both cases, you have the main constraint is the technology upgrading, which means that you may have nominally similar structure in terms of variety of infrastructure indicators, but it doesn't mean that you will do much better in terms of upgrading. I mean, I operate or work on countries, let's say, of European periphery, which in terms of structural features, when you look at the human capital, when you look at the even physical infrastructure, IT infrastructure, they are very good. They are much better than the income level would suggest. But that is then completely disappointing when you look at the indicators on technology upgrading, when you look at them where they are in terms of any of the indicators which we have in terms of technology capability or R&D capability. So there is a kind of something which is process in the growth process. Maybe the main constraints are therefore how do you convert favorable structure into the technology activities, which is at the end very much, I think, institutional process and the role of enterprises and something which William Lasdony called social conditions of innovative enterprises, how this process of technology accumulation, what it hinders it, and this is a kind of, again, $1 million question, but we can just see on a surface that similar middle income countries are much better in terms of structure than the results at the end show in terms of outputs.
I agree. I strongly buy your answer. In other words, you might want to emphasize this answer as one of the conclusion of the paper, saying that middle income trap is mostly can be explained by the first factor or intensity variable rather than openness or the infrastructure variable. And that's very important findings.
Policy, on the other hand, very much emphasizes, which is logical from political perspective, kind of the structural aspect in terms of infrastructure. Everybody is building their Silicon Valleys. European periphery now has lots of money where it's building R&D infrastructure. And in terms of that respect, is doing extremely well. But the issue is, then you are faced with the kind of level of technological capability in the business sectors, which is way behind it. So you kind of have a new structural weakness, which means that in your upstream capabilities, in terms of R&D capabilities, maybe you will be, in a few years, it will be much better. But in terms of your firm level capabilities, you are much behind. So you have a dual innovation system, which has a big gap between upstream and downstream, and there's nothing that connect them. This is something which Korea didn't have before in the past, because everything started from the kind of enterprise sector, and then it's kind of pushing. Now your problem is kind of this diversified structure or more upstream capabilities and link them, but other parts of the world have this kind of get and do not have these downstream capabilities in terms of firm level technology capabilities, production capabilities, which you had. So I have difficulties to put Latin America in that context still, maybe because it's too diverse, kind of, and don't have good knowledge. But the next one presentation will be on Latin America. So
I think so, but it fits perfectly well because this is the best way to announce that we should hear something about Brazil by a renowned expert who is based in the US, Nick Monotas, George Washington University. Nick, give us some more idea how it looks like in Brazil, and then we might come back and compare Latin America with the European experience. I have my own opinion about Europeans here, so I'm not saying it now. We're running out a little bit of time. That's why it would be good if we just hand over to Nick.
Thank you, Dirk. And thanks all the prior presenters, because they made the background that I need for mine. May I ask how much time do I have? Because I think we are running out of time, right?
Yeah, 15, 20 minutes, roundabout. So we make a shorter break and it's no problem.
So I expected that. This is the fate of the last presenter always. But I thought I would do something that will link this case. What I'm about to present here is a case, and if I can. What do you see? You see my screen here?
Yeah.
Yes.
Okay. So what I am about to present is actually a case of the type of things that the three previous presenters were talking about. It is a case of product diversification. It is a case of mission-oriented policy. It is a case of window of opportunity. It is a case of an effort of a government to leapfrog. This case comes from the biggest country, the biggest economy in Latin America, in fact, one of the biggest economies in the world, and one that is no small feat. It has developed one of the two most competitive agricultural sectors across the board in the world. It has one of the 3-4 most competitive aircraft industries companies in the world, Embraer. It has the 5th largest automobile producing industry. It is a leader in several other things, and many of those were developed at a time where leadership from the top could dictate avenues to the lower levels. Brazil was under military dictatorship, of course, for a long time, 20 years, 25 years. And during that time, actually, its industry flourished. It's not unique in the world. Korea also went through a similar process earlier on. So what I'm presenting here is a window of opportunity that opened up for the country by accident when actually the outside of a big basin. Let me show you where. If you see in this graph at the bottom, somewhere here, outside of Rio de Janeiro and Sao Paulo, there is in the so-called Campos Basin, they found huge amounts of oil. It looks like this. It's around here in the map. Huge amounts of oil, but however, are very hard to take out. This is one of the biggest finds since World War II. You see that we are talking about 2 kilometers of water and then several kilometers of rock, salt rock, before you reach actually the oil, which requires, in fact, when they found this, required significant capabilities that did not exist anywhere in the world in taking it out. So the window of opportunity came in the early 2000s when their leading oil company, Petrobras, and probably you have heard of Petrobras, when Petrobras then reached the point in capabilities to try to extract this oil. So in the early 2000s, they decide to order two large pieces of equipment to platforms actually to use out there and start taking oil up from the deposits. And at that point, the government in Brazil faced a huge problem. Petrobras wanted to buy abroad, to procure abroad to countries that could actually have the capabilities to create these very complicated platforms, oil platforms. And then the labor union stepped in and said, no way that we will procure outside. We will do it in Brazil. We know how to do engineering. We have some of the biggest construction companies in the world, which they do. And that is actually Brazil's space race. It's not different from a situation that we just heard about Russia and oil. It's a resource-based economy, amazingly rich, and suddenly it found yet another pot of gold, right? And they thought that they would use this in order to diversify upstream, and where? In the production of oil platforms and in the production of ships and the production of all the supporting equipment that are necessary for such a huge production. So Petrobras was actually getting prepared for something like this. As you can see in a publication that we have a special issue in the Journal of Technology Transfer in the year 2000. So Petrobras had been preparing for a decade about this, as you see in this graph, going deeper and deeper and deeper in digging in the sea. And by that time, it had become a leader. Petrobras in the mid-2000s, it was a leader, and it is still a leader in this. So they were calculating, this is an estimate of the times, they were calculating that this will take off pretty significantly in the future, and they thought on the back of this oil production, they could, as the labor unions were describing, could actually reinvigorating an industry that they had tried to create in the past, in past decades, and they had failed. And this is the shipping sector. So on the back of this major oil find, they thought they would develop some manufacturing capabilities, build ships, so shipyards, and build oil platforms for digging the oil out. The case in this chapter, in this paper, is about this. The country developed very elaborate policy regime at the macro level, at the meso level, which is the sectors, and at the micro level, which is the individual companies. So legislation, a lot of legislation was passed at the macro level to create the incentives. Petrobras was endowed with the biggest capitalization up to that point, $120 billion in the mid-2000s were guaranteed for this one company in order to spearhead this major push forward, right? In addition, there were legislations were passed about local content, which was determined to be between 45 and 70% local content of the equipment that would be produced for these industries, and guarantees. Legislation about guarantees, about who extracts oil, what is the role of foreign companies, and so forth. So the whole structure at the macro level was created. This was the Labour Party government of Lula, which is known in the world around the Lula government, and then at the meso level, Petrobras was actually determined to be the spearhead to lead all this effort. And Petrobras created special subsidiaries actually that would plan everything and intervene in the individual companies that will be contracted, right, to do this. What you saw in the first picture of the presentation and what you see now here is a number of shipyards that were initiated in different parts of the eastern part of the country, right? But in different states. This is where the oil exists out here, and the shipyards were created there by the big construction companies, right, to produce this equipment. At the meso level, then, Petrobras engaged in a very detailed planning about who is going to produce what. So much planning that really sounded like the old good socialist planning exercises. It was really determined who will do what, and how this requirement of local content will be adhered to. Now, the paper, if I really want you to read the paper, because the paper is based not only on secondary information, which has a lot, but it is based on a long series of interviews with people expressing opinions about what happened actually on the ground. And what happened on the ground, and this is the core of the story, is that the requirements were so significant, the pressures so immense at the meso and at the micro level, and the bottlenecks that appeared so many, that the structure became unmanageable. So even for a developing country, you see here the plans, right? I keep showing you sort of the plans that were made at that time. So you see here the ships and which parts and who would do what and so forth. So at the micro level, then the bottlenecks became so significant. So at some point in the late 2000s, in around 2007, 2008, they realized that they cannot do it on their own. So they invited foreigners to help them, companies from Japan, also Costco from China, Korean participants engaged to try actually to help these people to overcome the limitations that they had in building ships. Here is the history of shipbuilding in Brazil. As you see, it was in the 60s that they tried very hard to sort of develop this industry. This flopped. By the 90s, it was almost non-existent. And here is the big effort, the big push forward with this project. This is where we are talking about, which is also not succeeding. In the last few years, you must have read the newspapers, of course, that this whole effort resulted in a major series of scandals. And this is a typical story of a developing country where political pressures from the top with huge funding, guaranteed funding, do not understand that at the bottom there are certain bottlenecks, certain difficulties in order to create such a huge, push forward such a huge thing in a short time period. This was the problem, the short time period. The companies did not have time to develop these capabilities that they needed. So Ortrebrecht, which is a big company in the scandals, right? Ortrebrecht was the one big company, a construction company that was entrusted to build the shipyards very fast. But Ortrebrecht knows how to build a structure, does not know how to build a ship. It's a different story, and the other companies. So you see here on this graph the corruption and the car wash, the so-called lava jato or car wash in the West thing happened right here, and Petrobras, of course, is in the middle of these kinds of scandals. It's not that the company is corrupt. It is that it was given an almost impossible task, right? So, and a lot of money. That is a that is a recipe for disaster. The paper, essentially, the case argues that, as the previous presenters talked about, we have what we are talking about is very complex. It changes across the development of a country, and it involves macro, meso, micro level analysis. This is exactly what Brazil faced. In fact, I want to make sure that you understand that this is not necessarily the only case. In the book where this comes from, right, there is yet another chapter about the same country, about a similar situation of diversification out of natural resources. This is mining. Some of you may know that Brazil has some of the largest mine producers. In that case, the government did not create a huge plan, but it did help the companies. It was not really a top-bottom imposed issue, and the time was there, several decades, in order to develop. That example, which is developed by FGV here, Professor Figueiredo, in Brazil, is a much happier, has a much happier ending with the country fielding a couple of the biggest producers of the mining sector. So this is just an example, just a real case example of what my predecessors were talking about. This is the struggle that happens in a developing country to leapfrog and sort of diversify into related industries. The struggle of a country to sort of grasp a window of opportunity, which seemed quite large in the mid-2000s. Thank you.
So, thank you very much, Nick. I would suggest we make it rather short now, leaving a discussion a little bit out and taking 10 minutes break. But before we do that, let me remind or inform everybody listening and watching today that what you saw now, the 4 presentations, indeed you will find in the wonderful book which is published by Oxford University Press. The editors are, surprise, Professor Jeong Lee, Professor Coyne Lee, Professor Slavatosevic, Nicolas von Nortas, and well, I did also a little bit about that. So as soon as the book is out, we will be pleased to inform.
Right. Sorry.
So maybe you have another word for the book.
Me?
Yeah.
Yeah. So for those who follow this this meeting, the book is actually something is pretty exciting. It is edited by the people on this session. It's going to be published by Oxford University Press, and very importantly, it is open access. So people all around the world will be able to access it easily. As with the opportunity of publishing that book, which we hope will be in the first half of next year, we are running a series of workshops, if I may plug. The first one happened on November 4th. The next one that you can see on HSE's website, I guess, and all other universities' website is on December 3rd. Right? We will continue the discussion on such issues that we have today.
Yes, and we will keep everybody updated about the upcoming issues and events. So far, let me thank you all for the presentations, and let's go for 8 minutes break, continue at 3 o'clock. Thank you.
Sorry for taking the break.
What should we expect? Come on, Rio.
So we are done, Doc? Our session ended?
Yeah, I think we are on a break.
Okay, thank you.
So I think most of us are coming back now. I'll just wait another minute. Or maybe two. Okay, welcome, Dr. Kerkrosh. I will announce it publicly. Don't worry, don't worry. This is a nice reaction. All right, so let's continue. Part 2 of our workshop session is actually complementing quite nicely what we had in the first part when we talked about capability upgrading and the like. We will talk a little bit more now about requirements and new requirements for innovation policy with a quite a strong focus on measurement and comparing and also looking at the heterogeneity of different systems. In the first instance, I welcome Sandrine Kerkrosh, who is with the OECD and who has a very, very profound understanding of STI policy. She was in charge of the STI outlook for quite a couple of years at OECD, and it's my pleasure also to publicly announce that Sandrine yesterday only defended her PhD dissertation at Berlin Technical University, which allows me now to say welcome, Dr. Kerkrosh. We are looking forward to your wonderful presentation, which will be about comparing, benchmarking different policies. I give the floor to you. I think you can upload your presentation on your own, and it should work nicely.
Thank you very much, Dirk, for this nice word. I'm really happy to be here with you this morning or this afternoon. Indeed, I would like to share with you some insight on how we could benchmark national innovation policies. So just, I need to access my screen. Let me stop just sharing once.
Sandrine, yes, we see you.
I have some trouble sharing my screen. That's the first time, I must say.
Yes, now please press full screen button.
Full screens button. Where do you see full screens button?
The line below.
The full screen will be on your presentation, Sandrine.
Yeah, but I can't switch to PowerPoint. I don't know why. Okay, let me do this. Okay.
Maybe you try to press F5. Yes, that's correct.
Can you see the screen now?
Yes, yes.
Okay,
yes.
so I'm sorry for this technical issue. So basically, yes, when we look at innovation policies, the first point is that there is a growing complexity in the way these policies are designed. Rising expectation, we expect innovation to address much more challenges, productivity, of course, but also environmental or societal challenges. Innovation, we understand innovation in a much broader way, non-technological, open innovation. There are more actors and networks involved in the innovation process. The globalization is also blurring the frontier of national policies and increasing the transnational externality. So we are in complex systems where multi-dimensional interaction are at stake. This raises the question of how government, how public policy could intervene and be efficient in such complex systems. This requires, of course, a whole of government approach, and also taking into account the interaction, complementarity, and tension between policies. For this, we need a policy mix approach. We need this approach at the core of the design and evaluation of innovation policies. But at the same time, we face a lack of evidence on how these policy mix are shaped, a lack of evaluation. We have some evaluation about the instrument mix or interaction between 2 or 3 instruments, but not much. And we also need more information about policy processes, history behind the way these policies are shaped, implementation structure, and covering a broader range of actors and toolbox. So we conducted some research to try to understand what are missing, what are the limitations today in the way we are benchmarking innovation policies. And we found, based on the literature, based on a comparative analysis of international benchmarking exercise, basically those that have been conducted by large international organizations, European Commission, OECD, or UNESCO. So we find 3 main caveats. One is a gap in concept. Second is a gap in data. And third is a gap in data management systems. The first gap in concept, we lack shared standard, we lack minimum uniformity in the terms, in the way information is collected. And this, of course, is a barrier to benchmarking, is a barrier to integration of information systems, and a barrier to data exchange. Concepts are not clear-cut, and very often there is confusion or overlaps between an objective and instrument. So even if these 2 concepts are very much linked, these are not the same things. And we have some unsolved issue regarding how we quantify, for instance, regulation or soft instrument, non-financial instrument. Then we have a gap in data. So often countries do not have the internal capacity, infrastructure, arrangement to collect policy information and the type of information that would be needed. Starting, for instance, with budget, with the popularity of uptake of initiatives and the outcome. There is also some inadequacy in the measurement toolkit, in the sense that our statistical system have been developed along a linear vision of innovation, very much focusing on R&D, very much focusing on the S&T part of the STI landscape, so patent, R&D expenditure, publication, and much less on the non-technological segment of innovation. And then we have a gap in data management systems, because most of them have been designed on the traditional relational database model, which means that we have some typology and we map this typology within table of correspondence. But this type of system are to some extent quite rigid, and they struggle, or even they do not evolve fast enough as the subject they are dealing with, which is innovation and innovation policy, is changing. So what to benchmark policies, innovation policy, what do we know? We need to compare the composition of these policies, so components, their balance, and we also need to map and to measure their interaction. We need an operational definition. So in a definition that go beyond this instrument part and integrate rationale and arrangement, that identifies these 3 components: composition, balance, and interaction. And we need to define this component, define the areas of interaction, and set some structuring principle for organizing data collection, management, and analysis for thinking and also for processing the information. In terms of structuring principle, what we experienced and we tested is first to identify the unit of observation. The unit of observation is the policy initiative. Then we need to adopt a criteria of selection and a threshold, because when you map a policy mix, you don't need to have all the information, all your component at hand. What you need is to focus on the major one. The literature is quite consistent in this area that we need to focus on the most relevant, the most meaningful and important. And for this, there are 3 approaches. One is to focus on budget, another one on the expert view, and a third one on government view. Regarding budget, we face again some issues with data availability, relevance in some cases when I mentioned, for instance, regulation, and also it's a very complex issue to harmonize budgetary information across many different countries. For the expert view, we have the issue of the selection of experts. Who will be an expert? Who will choose them? Which methodology will they apply? And will this methodology be consistent across country? And is there a consensus around the choice and the methodologies they use within the country? Because we need a consensus at the country level to be sure that the result of our analysis will be effectively considered and used. And then the last option is government view. The government itself chooses what are the major initiatives in its own country. But this includes some political bargaining and a minimum of internal coordination in the country. And then the last point, we need to quantify this unit of observation to find the balance. And we also have some different approaches. One is to use the input, how much money, public money can go in there, output, outcome, impact, or again, expert view. Another approach, much simpler to understand and to apply, is counting the number of initiatives, which allow to account for non-financial instrument regulation, for instance, but also have a very strong caveat. It overlooks the magnitude of policies. And then we need to identify the areas of interaction in this mix. So to give you an example, policy goals. Goals give us a rationale, justify policy intervention. Typically, we could have some tension between a productivity agenda and an inclusiveness agenda. If we look at different policy domains, we could also find some tension, for instance, between the tax policy, innovation policy, and the climate policy agenda. If we focus in a specific policy domain, so with its own strategic objective, we could find some tension between public research and private investment, for instance, in R&D. We could declinate this approach and could find some complementarity or tension between targets, between instruments, between different geographical space, so between, for instance, national and regional policies, and across time within a same country. This area of intervention are actually the property of an initiative. An initiative, a policy initiative, could be defined within a policy domain, a geographical space at a specific time, serving specific one or multiple policy goals, one or multiple strategic objectives, being used many or a single instrument, and be more or less targeted. This also provides us the foundation for typologies. Then how do we translate this mapping into measurement and benchmarking concretely? Actually, this mapping of initiative, is providing you a type of scatter plot of initiative from which you could process some further analysis. First, about the demographic of policies, how these policies could have changed, be renewed, or be replaced over time. You could develop some indicators on the composition of this mix, of this scatter plot, on its governance as well. You could process some network and cluster analysis to find the connection and interaction. And you could also intend to produce some empirical analysis. And what I would like to show you now is some application we have tested over time using this methodology. And the first one was published in the Outlook, OECD STI Outlook in 2016. It was about the demographic of policies, where we highlighted that commercialization of public research was one of the most active STI policy era since 2012. Experimentation, we also did it regarding technology diffusion across two main channels. One was the technology transfer by university and PRIs, and the other channel was technology upgrading through global value chains. What we have looked at this policy mix from different dimension perspective, but to give you some flavor of the conclusion, first, it's that all countries have policy in place to support technology diffusion through these two channels. But the policy mix are very polymorphic and very different, even in the same country or in the same given areas. So for instance, technology transfer, it's much more at the crossroad of public research for some country, or business innovation and entrepreneurship for others, or industrial policy again for other countries. So we clearly see an orientation to a more supply side or demand side policy. We also see that platforms and networking infrastructure are much more popular instrument in this specific domain, followed by financial instrument. Now, if we turn to technology upgrading through GVC, we see much stronger emphasis on industrial and cluster policies with a range of promotion policy for international investment. And in this space, the financial instruments are the most important tool. If we look, for instance, at the density in the policy mix, which means that the density of initiatives that could be implemented in for a specific objective. If we look at technology transfer and just the initiatives that have been identified as aiming to improve technology transfer as a primary objective, we see that 6%, 40% of the mix are dedicated to this main objective. Now, if we look using a text as data analysis method, if we look at the broader policy mix and other initiatives that could be indirectly aiming to foster the technology transfer, we see that the density of initiative is much larger, going from 29% to 53%. We have adopted this same approach for other strategic objectives, so increasing participation in GVC, for instance, or increasing the structural transformation and technology upgrading. And we see that by looking at a broader mixed, a broader initiative, we, to some extent, find some signs that this strategic objective are mainstream across a broader range of initiatives. And this would signal some more intense combination of instruments and across a broader range of policy domain, for instance, for technology transfer than for participation in GVCs. Also, we can see very strong differences across country, and the policy mix are very context specific. So I'm not saying something really new, but we can see it concretely with this exercise. We see that the mix are much denser in more advanced research system, for instance, and more broadly integrating into a broader policy mix when we attempt to technology transfer, which would signal first some greater policy sophistication in more advanced research systems, an accumulation of initiative over time, and as I mentioned, the mainstreaming of this objective into a broader policy mix. When we look at more advanced economy as well, we can see that they are more likely to develop or to deploy platform and infrastructure, which are more costly instruments to support or to attract international investment. We cannot see really some incidence between this density of difference in density, in policy density for GVC participation. So it seems to be quite universal topic, but we see a greater incidence on promoting structural adjustment or technology upgrading. We also see some difference, for instance, for smaller and larger firms. Larger firm will have a less initiative, less dense policy mix for integrating GVCs. They are their own supply chain and domestic market. We see some difference for federal state, for instance, as well, where they will tend to use much more governance arrangements, for instance, to increase participation in GVCs, while other countries, more centralized country, will use more, as I mentioned, financial instruments. And we also see some higher likelihood for country to design their policy mix in terms of technology upgrading based on their prior positioning in GVCs. So what I would like to stress here is more like this methodology can help us better benchmark, categorize, and see how national mix are shaped and understand the reason why. We also are conducting a new exploratory analysis now. So it's new material, not published, and I'm happy to get your feedback on this. It's a network analysis of AI, artificial intelligence policies, and to which extent they are targeting SMEs and entrepreneurs. Here, what you see, it's the case of Korea. So institutions engage in innovation policy national innovation system in Korea, and just that are more specifically having programs, policies in place dealing with AI, so the AI innovation and AI diffusion, and just that in addition are specifically targeting SMEs. And here it's a visualization for Korea of a quite centralized policy system around the Ministry of Science and ICT. Each node is an institution. The link between the nodes are joint initiative, and the size is a number of initiatives that is administered by the institution. So if we look for another country, Netherlands, we can see that the case of Netherlands, it's very much different with two loci, Ministry of Education and Science, Ministry of Economic Affairs and Climate Policy. If we look now at another country, US, it's a much more decentralized system with some influential organization across different sectors and era, but no specific focus on SMEs. So what has been achieved? We have now a more robust and objective framework for assessing policy mix, a methodology for benchmarking these policies with some granularity, and also some now clear identification of the area of interaction. And we have a series of experiments that help us consolidate the approach, revise the principle and typology. We have an architecture. We have also a unique source of country-specific information, since based on this data collection and this methodology, we have built a STI policy database back to 2012. The first pilot was 2012. This database has been revised, consolidated, and in 2017, it has moved to a new semantic technology environment and giving birth to this new generation STIP compass with 67 countries. And we are, to some extent, a more widely shared consensus since 2016, the European Commission and the OECD are collaborating for the maintenance and the development of this infrastructure. What is still missing, what is still unsolved, is this question of quantifying certain aspects of the policy mix, the governance arrangement, the regulation. So the literature gave us three options, which were input, output, or a simple counting. But now the question is, could we combine this approach? Could we combine a budgetary approach with some indicators, with expert view, with government view, or is it a full avenue of work? We also have an issue regarding, and it's the same for all survey methodology. We are very reliant on the respondent and their constituency. So for instance, when conducting this work on AI and SME, I realized that the policy mix for AI was extremely strongly oriented toward large S&T programs, technology push mechanism of diffusion, and not so much market pull mechanism. There is also a question of agenda, because the respondents to this survey are OECD and EC representative in charge of S&T, research, and innovation policy agenda. But there are some issues that are not considered or not discussed, because basically they cannot cover all topics at the same time. So for instance, we are missing the supply chain and market diffusion channel, which are actually the main channel for innovation diffusion towards the business sector. We are missing some information about the skills. We are missing information about the business environment, which also determines firms' capacity to adopt, capacity and incentive to adopt and take risk. We are also missing some market and competition conditions. We still face this issue of uneven quality and capacity across country. And this is I believe in a virtuous process, a virtuous circle, where because we have done this work, because we have demonstrated we can do something with this work, this increased incentive to invest in data collection and invest and for country to do this exercise that is extremely burdensome and difficult. And we also have started better understanding the era of interaction in the mix, but we are still not addressing the question of what are the nature of interaction. Are they positive, neutral, or negative? This is something that probably needs further conceptualization. And we also have new research avenue. And here, I mean, I've been developing this work for 10 days now, 10 years, 10 years. And I still have the impression that I'm only starting. We could look at the different dimensions of the data set, new countries, because for the time being, I only worked with a handful of countries. We could work better with budget, but also to track this distortion towards large-scale S&T policies. We could further dig into this idea of mainstreaming, and this is what I'm currently doing with looking at SMEs policies. And we could look at sub-part of the policy mix. There are also some different axes of analysis we proposed, and the demographic of policy, stability, predictability, this has been almost untouched. Network analysis, we could do much better connecting the governance structure. We could also further develop descriptive statistics. We could expand and experiment this framework to new policy spaces or new level of governance. And I already started working on this, for instance, by trying to better understand how the combination of SME policy, innovation policy, local development policy, and international investment policy could better help for SME to benefit from the spillovers of international investment. And last but not least, we can make a better use of emerging technology. The semantic technology could help us to improve data collection, but also to better bridge information system, natural language processing, machine learning. Is there a way for us to better use this wealth of information that is available in countries, in regions, in institutions, in agencies, and that are, for the time being, really underused? Thank you very much for your attention. I'm really happy to be there today.
Thanks a lot for your talk. It's even improved against the defense yesterday. Oh, I thought this was the end already, but there's never an end for improvement. So I might have a number of questions, but I will not raise it now. Just open the floor. Anybody else has a question or a comment to give? If not, we just continue with another measurement question. Not measurement in that sense, but more the question, is there a need for measuring it? Is there a need for information? And I believe we have a wonderful, strong speaker here, Mario Cervantes. This is our second OECD slot today. Mario, I give the floor to you.
Thank you, Dirk. Hello, everyone at HSC. It's nice to be here. I'm not sure if you can see my screen.
Oh, we see your name, but we don't see your face. Oh, no, we see you.
Hello, everyone. It's going to be a hard act to follow. Sandrine gave a very impressive tour de force. Mine is more of a reflection that's only beginning, so we don't really have a conceptual framework for this, but it's just maybe to raise some points for discussion. Let me share my screen. Here we go. So one of the questions we've been looking at is international cooperation in science and technology, looking at some of the current trends and policies. But through that exercise, one element that has come up is, the changing needs for policymakers. Oftentimes, of course, the indicators are always lagging behind the questions in government ministries. Technology is moving very fast. Digitalization, the change in global value chains really challenge the current infrastructure to keep up. When we think of international cooperation, it's quite a field with many actors, public and private actors. I mean, some of the most famous things that are familiar to people are things like the International Space Station, the cooperation that's funded through Horizon, development cooperation that targets developing countries, and increasing capacity for research in those countries in specific areas like agriculture or energy. That's just to name a few. So it's quite a vast field. The motivations for some of these actors are different, and that's going to have an impact on the indicators we develop. The research community is the scientists, the universities, the PROs, ministries involved in that. Their focus is here on improving quality, sharing costs. So they're going to develop indicators with that in mind. New actors are important in this area in the development world, philanthropies and NGOs, but generally they have very short-term funding cycles. They have very specific agendas, and they're going to focus on case studies or collaboration. At best, we can get indicators of funding. International business, that's a big area for measurement, looking at flows of funding across countries. In a lot of OECD countries, some of the smaller countries, businesses fund a lot of the national R&D efforts. So it's a very important element to understand. Then there's, of course, the foreign ministries, the whole science diplomacy element, which is another aspect of international cooperation, bilateral and multilateral agreements here. A lot of this focused on supporting other diplomatic initiatives, whether it's economic or security initiatives or cultural and peace building. And here the principles are going to be quite different than what you find between universities that focus on improving the quality or accessing leading research. Here the issue is around mutual gain, reciprocity. And then, of course, there's the international organizations which are part of the global community of science and technology, but they have very specific missions. There's elements like the international nuclear agencies, the International Energy Agency, which have a mandate on things like clean technology or doing research in specific fields. And this is international driven. Of course, there's also networks of universities and funders working together on specific challenges. A lot of this around the global challenges like the Belmont Forum initiative, for example. This is just to give you an example of the range of actors in public research, from the individual scientists who have their own, especially when it comes to basic research, and then the performing institutions, which have their own international logic, and of course the different funds. So here the internationalization will follow the path depending on the top-down policy here, whether it's the internationalization strategy of the Higher School of Economics, the Fraunhofer Institutes in Germany. And then there's going to be, of course, as I said, a lot of the spontaneous cooperation that happens among scientists and networks. And this is a more challenging area for measurement. So international cooperation, there's a lot of visible parts. There's, like I said, the internationalization of business R&D, the share of foreign funding in gross expenditures on research. There's issues on co-patenting, the co-invention across borders, co-publication. That's a very big science of bibliometrics, that one that I know the HSC is very active in. There's a more challenging one around international mobility of students, researcher mobility. The OECD had a program on careers of doctorate holders, looking at that specific population of PhDs, and also within that project to study the mobility of those researchers. Now, some of the other work that's available in the middle section of this iceberg, there is some work is the issue on scientific network analysis of scientists around the world, the scientific diplomacy area, the overseas official assistance funding of STI, which is a challenging one because they don't use the same definition of STI of the R&D of the Frascati manual, for example. There's that space of technology that's embedded in equipment and trade. There's some of this is captured through trade statistics, licensing statistics of technologies between companies, purchases of royalties. That's one intermediate measure of this cooperation, which is more of a transactional than a relational. And in fact, I'm going to argue that most of the measurements we have focused on the transaction rather than on the relation. And these are one that are in the hidden part of the connections of between institutions, the relations between embodied institutional agreements, the relations between scientists, the relations between people and companies, the relationship between the financial markets and these multinationals in terms of their investment strategies, the people on the board. All of this is hidden. When Intel expanded into Israel, it was very much because one of the top people at Intel had connections to Israel. So this would not be covered up at the top in terms of what's visible here. And there's a whole transformation happening with artificial intelligence and data-driven collaboration, automated machine learning technologies that are enabling cross-border collaboration that is not captured in any of the statistics. And then there's, of course, another part, which is the technology clusters in countries and their own relationships, clusters collaboration between Taiwan's semiconductor clusters and the Silicon Valley clusters. These are not captured in any statistics. This is sort of the invisible part of the iceberg. So just to show some of the standard statistics about the increase and what's measurable, we can count what we measure, and co-publishing data has been one of the biggest indicators governments use to understand the benefits here being the helping countries improve the quality of scientific research. We see that there's also ability to map the actors in this cooperation. So this is from the EU, looking at the main partners in international co-publication between EU and other countries. China, of course, being one that's become an important partner for the United States, but also the EU, and to a lesser extent, Korea, a bit more in Japan. As I said, scientific cooperation is correlated to impact. So there's a lot of support evidence for international cooperation, and these indicators are used to shape policy and argue for international collaboration among scientists globally. This is also from our colleagues at HSC about looking at the share of collaborative publications in the total number among the BRICS, and we also see a strong increase here amongst BRICS countries as well. On the business side, the data becomes a bit more complicated. The inward bird data has shown that there's a lot of an absolute increase, but not in relative terms globally. This is also where the data gets patchy, is that we don't have very good measures of services. Now with digitalization and globalization, the service sector is becoming much more important as a player for innovation, especially in digital. And this is not captured very well by current statistics. This one is based by Bernard Dax, who's at the Austrian Institute of Technology, who used the data from the US Bureau of Economic Analysis to show the rise in services in international R&D. But we don't have this for most countries. This is one of the other indicators that we do have on the business enterprise. And as I said, for many small countries, the business share from abroad is 5 to 10% of their effort. Other sources include the commission funding of government and higher education. so we can see the importance that EU funding plays for certain countries like Germany and the UK. And this is important in the context of Brexit, for example. There's also data on the US, and about 5% of the US federal funding goes to international research, but here it's spread across the different agencies. You see what the share from the NASA presents from different organizations in the US. This is also from another way of measuring this is the participation of European institutions in public R&D programs and the share that the countries have participated. So for example, for France, you see a large participation, more than 50% in Horizon 2020, but also compared to FP7, and then also increased participation in the joint program. So there's patchy information of who's cooperating with whom. This is another source, but this one comes not from the labor force or census data, but from the scientific authors data, looking at international net flows of scientific authors. So despite the indicators we have, you saw a range of quite impressive indicators. There's a lot of gaps that remain, both in terms of the current indicators we have and the new ones that policy is emerging as we've seen. I mean, one of the points that I take is that many of the indicators focus very much on the actors and the actor needs in terms of input and output. So we're looking at government spending, we're looking at public sector spending, scientists co-publishing, business R&D flows. This framework is very much designed to assess the intensity of the collaboration in the inputs and the outputs. But as I said, there's some gaps in that framework, the R&D in services, the ODA, official development assistance persistence. The big challenge now is trying to measure international cooperation on grand challenges, because grand challenges themselves are multiple, cross-disciplinary, and interdependent. So measuring research that will tackle, for example, clean energy or agriculture will be much more complicated than we have been able to do so with current indicators. The relational indicators are missing in all of this. We don't have relational indicators among the actors. Digital platforms are important for collaboration, and there's a need to think about how we could use things like science clouds, citizen science to measure the intensity of relationship cooperation. And then the point of the directionality, because we don't measure the direction of R&D funding for social economic objectives in a very precise way. We're not able to measure how much R&D is going to poverty reduction or to some of the other SDGs. I think the next frontier here really is about, and maybe this is a challenge to the HSC, is about AI and human-based collaboration as science becomes more data-driven globally. So automated collaboration, automated machine-enabled open innovation, a collective intelligence through these processes. I think that's something that's a bit way out, but I think it's something that's happening so quickly that we need to maybe reflect on what this could mean for measuring who is leading in terms of international cooperation. So those are some preliminary thoughts on this topic. We have, as I said, a framework that's useful for a lot of the basic purposes, but there's a lot of questions around responding to policymakers on how to direct funding to the grand challenges, how to analyze the impact of digitalization on cooperation and vice versa, how cooperation is changed through digitalization and AI. And this is not something we've started to work on at the OECD. We have a very incremental, this is maybe where some frontier thinking amongst researchers could be a challenge that I'm putting forward. Thank you very much.
So, thank you very much, Mario. It was a wonderful compliment to our first talk. I think, looking at the time now, maybe we allow one or two short questions, if there are any. I didn't see any in the chat, so are there questions in the audience?
Dirk, I have a couple of questions, but I don't want to intervene now, perhaps at the end.
Make it two, maybe one or two.
Yeah, it's for the two speakers. I wanted to ask Sandrine, it's very nice, the work it has been developing for a long time. If I was a government official, I would like to know what I have to have absolutely. Without it, I cannot move forward. What is the necessary condition? What I should have probably, and what I need to think more generally then for the specific case I have in front of me. So I don't want her to answer. I want her to tell me whether her research is going that direction. That's all. Yes or no? Are we trying to get into the necessary conditions, the sufficient conditions later on and so forth, so that or not? And I wanted to ask Mario, another great presentation, whether this data is indeed very, very useful, because as we see, globalization cannot go one direction, it can go a different direction as well today. And whether he sees future with his data in sort of giving us solutions for the new brave world that we are creating.
It's Attila Havash. May I ask a question to Sandrine as well?
Sure.
It is somewhat similar what Nick has asked, but from a different background or different approach. Because so my question is whether the main aim of your analysis is to provide a tool for comparative analysis of STI policies, or a tool for benchmarking STI policies. And so perhaps I can reveal what is the difference between Nick's approach and mine. I don't think that anyone is in a position or should believe that he or she is in a position to tell any government what is a necessary and what is a sufficient condition. I think the context does matter. So that's why, in my view, what is really useful is to provide comparative analysis of STI policies, but not a benchmark, not a league table of countries in any respect. From a different angle, I wonder whether how the national governments perceive your project, your effort. What do they want to get from the OECD in that respect? My hunch is that unless you are in a top 3 position of a perceived league table, you don't want to see a league table, a scoreboard.
I think here we come to a crucial point. Let me give an answer in brief in advance. This is not going about a scoreboard, but it's not going to be about a ranking. So Sandrine can tell you more. It's going much beyond this ranking stuff and the evaluation, etc., etc. So be aware, it's not the Global Innovation Index 2.0 or Innovation Score. No. Sandrine?
Yes. What would be useful for a government? I would tend to think like Attila said. This is not to us to say. We can provide tools, we can provide information, we can provide evidence, but then this is up to them to decide according to where they want to go. So it's about, the question is related to how to design a strategy, and for a strategy you need a vision, you need an horizon, you need to understand where you are. And this type of exercise is more to understand where I am, what other countries are doing, And if there are countries that could be in similar situation as I am, is there something that I can learn from them? So then to answer the question about league table, this is not a league table, this is not a scoreboard. And actually the indicators were, the preliminary indicators we have developed have not been used to say that one country is doing better than another. They have been used to say, okay, we see some differences across country. How could we explain this? And then in the research work, there were some time spent on explaining for each country why we see these differences. For instance, we see more focus on public research than on entrepreneurship, academic entrepreneurship. There are reasons, there are structural factors that could explain why a country is putting more efforts in one direction rather than another. There also are some aspects that cannot be quantified, and that's part of the difficulty of the exercise. There are some culture, there are some social values, some beliefs in the way policy are designed, shaped. There is an history as well, some arrangements that are there, and that also contribute to explain the result of this exercise. So, and really there is no intention to say it in very quantitative way that one country is doing better in this type of area than another. And I think it has not been done so far, and I doubt it will be done because it will be extremely difficult to analyze it, to make sense of it, because the results are very country specific. So it's more a way to visualize, to frame the differences and to identify some similarities. So I see this exercise more as a tool for mutual learning than for competition.
Thank you. Just the reason I asked this question is the title of your presentation, because then the magic word benchmarking is in the title. And benchmarking suggests that there is a best performing country and you compare all the other countries to the best performer. But I'm very happy to hear that this is not your intention.
No, it is not. And thanks for pointing this. I may change the title of my presentation if it's right.
Yeah, there's a term which is not widely used. It's intelligent benchmarking, which is practically what that covers what you have just explained, that your aim is to provide information for mutual learning. Thank you.
Okay, Mario?
Yes, to answer next question, it's very hard with the current data even to say things like, is international R&D increasing? Because we're not capturing services. So yeah, I can say based on the data we have, yes. But you know, I think this is one of those areas where combining data with GBCs, for example, we know that, as you said, globalization has taken a hit here from the COVID crisis, but there's also been accelerating other trends like reshoring or shortening global value chains. These things are happening, so we would need to also look at what's happening on the input-output data, financial data, to get a better, more real time. Of course, with indicators, we're always looking back. I mean, even the OECD, the best OECD indicators are 2 or 3 years old. This is where the alternative metrics people that are working here at HSC, this is where I think combining that to give a different spotlight on the standard indicators is really going to become more and more important, because I think we're going to struggle with the standard indicators to help policymakers more and more. Thank you.
Okay, thank you very much. I think we should come and listen a little bit about heterogeneity of strategies. Vitaly Rud luckily volunteered to give us a short presentation on that. Vitaly.
Yeah, hi. Thank you for this fantastic opportunity. It's a pleasure to see familiar faces, but also I hope this short presentation will be interesting to a broader audience. It is heavily based on the book which has been already mentioned, this Oxford University Press book on technological upgrading. However, I added some more stuff to be consistent with what we heard from Sandrine and somehow with Mario's ideas. I will, as soon as the time is really short, I will concentrate on the main things, not going into the detail. You may find details in the published text. Also, many of you already heard previous versions of this slide. So one main idea that we get from almost any area of contemporary growth studies, but specifically focusing on the technological upgrading, that we need quite sophisticated concepts to understand how the things work in reality. For example, the technological upgrading agenda is it is quite clear that it goes beyond conventional sectoral myopia. Let's say everybody needs to facilitate high tech. That it is much more sophisticated than the idea that the economy must dramatically increase their R&D investment and so on and so forth. So basically, the upcoming evidence shows us that there is no unified pathway, and we need to decompose these ideas of technological upgrading and shift to better growth models to some other primitives, to some other building blocks. And it appears that innovation capabilities is one of the very appropriate concepts to, let's say, to seek for, right? So basically, the idea of changing to better growth models is about planting, multiplying, and scaling up innovation capabilities, abilities to use, to generate, to use, to spread new knowledge, to adopt best practices, and to become more and more frontier, right? And this, in its turn, raises the question, how do we actually account for these capabilities? The point is that it is so much easy to say this is a buzzword, innovation capabilities. However, the reality is that measurement, accounting of innovation capabilities, particularly accounting of innovation capabilities, given the heterogeneity of different innovation strategies, is still a problem which is not, let's say, 100% solved, but I mean, maybe 10% solved, I should say. Right? Okay, saving time. This presentation focuses on the idea of using business tendency surveys, I should say, or innovation surveys. In our first presentation, this section, Sandrine was mentioning advanced methods of text mining, right, to analyze what is going on with the policy mix, with the policy mix that happened. I would say that so far, in addition to these fantastic advanced techniques, still the most straightforward techniques of analyzing data sources which are already available are still underused. Basically, everything which is connected with different areas of structured response from the targets or from the actors of innovation processes. Innovation service is one of the most well-marketed tool in this area, right? Because it is internationally harmonized. Many countries, like 80 countries in the world, do it. But okay, we still remember that it is just a survey, right? So enterprises express their opinions. We can match it with some more hardcore data like economic performance, but we still remember that it is a survey. However, the point is that even a survey, even the structured feedback on the business environment and business tendencies may be better than nothing to guide the sophisticated policies, which are really actually without this evidence, without the appropriate evidence, at least of any type of precision, they are basically hanging in the air. And that's why I'm still advocating that innovation policy, innovation surveys are worth exploring in a deeper way, right? Why? What is the power of such type of facilities as this business tendency service or innovation service? Actually, the point is that we can tweak and we can really construct the measurement frameworks that correspond to our needs. And innovation service, for example, this, if we talk about this technology upgrading discourse, the discourse of collecting the innovation capabilities, we can find directly the relevant measures, we can construct them, and we can have full scale of these indicators, including the microdata level, right? And to save time, right? If we try to use this sort of microdata indicators, we can come to unusual conclusions. For example, observing the trends, the micro-derived but macro-aggregate trends in the dynamics, we can support our judgments. For example, whether actually our system, national innovation system, is moving somewhere or it is like hanging back, or what happens actually. And we can be very much substantial, at least, okay. Of course, this thing is subject to cross-validate with different data sources. However, it is like definitely an indicator of state or progress, right? We can do this exercise even at more detailed level. For example, these are the parts, again, described in the original paper. We could classify the industry level in innovation capabilities, right? This procedure allowed us to distinguish between 5 different levels of innovation capabilities within industries. Non-innovative, barely innovative, modestly imitative, that means focusing on imitation, broadly imitative, mostly imitative, actively innovative, right? 5 levels of innovation capabilities. And the power of innovation service is that we can actually trace the dynamics of industries between these levels of innovation capabilities. We may observe what industries are actually upgrading their capabilities, which industries are, let's say, maybe even downgrading. We have these cases here, right? So over the horizon of 16 years, we can see some dynamics. And this micro derived way of doing things helps us to overcome the stereotypes and biases in terms of where do we expect to find innovation in our country, right? As soon as we believe into a harmonized manner of the survey, right, that it is equally applicable to all sectors under discussion, we can really compare the firms at micro level, and then we can find in which sectors they actually operate. And this helps us to show to construct such pictures and to discuss what are the sectoral effects of this. We can have a bunch of interesting implications from that. I don't want to spend time on discussing these things. You can, again, soon you'll have the opportunity to read it. The point is that it shows actually the diversity of the area, this complex area of regulations, innovation. And the point is that there is a challenge for a state. A state introduces a policy mix, right? Okay, the world has bought this idea thanks to OECD, not, let's say, not the last part, this idea of policy mix, right? This idea appears to be very correct, I think, that there is a superposition for this complex area of regulation. Only a superposition of metrics, of policy measures might move us forward. However, the point is, what are we focusing at in this superposition? Are we focusing at some types of behavior, or we are focusing about some ideal understanding of what is an innovative company? Maybe we are designing our policy mix to favor only the most fantastic firms, best to the let's say, operating at the frontier. However, if your country has 99% of firms which is not operating as a frontier, and the policy mix is designed based on wrong assumptions on this proportion, your policy might fail. Also, the point is whether this policy mix has a, let's say, a static perception of targets, or it is a more dynamic nature. Do we really understand the composition of strategies that we have within our economy, and what is the transition trajectory to different state, right? To the new state, the changed state. Is this policy mix providing them with the proper incentives to change? This is an open question. And that's why actually this point of discussing the heterogeneity and analyzing it and accounting for it is very important. There is a short extra illustration, how we can proceed, right? Introducing a bit more systemic view from the positions of national innovation system development. I now follow the classification by Boros and Edquist on this functions of innovation system or activities of innovation system. The point is that we can illustrate, using these tools like business tendency surveys or innovation surveys, we may ask the firms what is actually the aggregate effect of the existing innovation policy, which is happening right here, right now, on your performance, right? And okay, we can ask it not in such a blunt way, but we can ask them for different aspects of this. Did the state help you to do some new products or processes, innovation, engage into new innovation projects, right? Intensified your innovation expenditure. Do you feel that it helped you to lower innovation risks, whatever? Okay, so that was the question by design. And these options, in fact, are implicitly connected to this classification of aspects of national innovation systems by Edquist and Boros, right? And we can estimate what, of course, it will be a kind of a self-estimation, but however, it's the metrics. How does the targets of regulation feel? How the existing policy mix actually helps them, right? Here is a chart on the left side of the, it is like a round diagram, right? So this lens shows what share of the respondents said that they have this effect, right, from this list. And it appears that there are clear gaps observable from this picture, right, from this petal, from this flower, right? So there is a dominant focus. Most of the respondents say that the state helped to allocate more resources for innovation. What was completely missing, that the existing policy mix completely failed to initiate new networking. Facilitation of search function was not actually working. And knowledge generation also nearly not affected by the existing policy mix. The point is, I don't go into the details. The point is that we actually can decompose it further and to understand how exactly the heterogeneity of factors reacts on that policy mix. We can identify what firms actually benefit more or less. It's quite interesting that, well, I mean, you could talk for a long time even for this slide. It's quite interesting that most of the effects, for example, here are experienced by the organizations with really open innovation process, not coming into the detail. Then the firms which are more aimed at complementary innovation strategies have considerably more expressed effects around broad range of dimensions. Interestingly, that the major target of firms which benefits from the existing policy mix are the firms that actually aimed at import substitution and which was strong in the public agenda for some ages, but it is an interesting illustration. On the opposite end, technology push firms, which actually want to commercialize their results, are less beneficial from this existing policy mix. Last but not least, the diversity, the inequality of in terms of technology level, right? So the firms are not homogeneous in their technology level. It's interesting that at this point the policy mix is not that selective in terms of effects. So basically, it distinguishes between active users of any types of technology versus non-users of technology. However, the firms that are more closer to the technological frontier seem to benefit in a better way from the existing policy mix. This is good on one hand, but on the other hand, let's question ourselves whether the laggard firms are enough supported by the policy. Okay, so the conclusion, definitely we are now in the state of urgent need for this, let's say, better accounting of heterogeneity of innovation capabilities accumulation. Could we say that we are moving towards the computational science of technological upgrading, combining these text mining methods that, for example, Sandrine illustrated, or this bottom-up in-depth analysis of firm-level data? However, it's quite clear that we need this to fuel this conceptual discussion. One point that was raised at the previous discussions on this text, this requires more and more development of what can be called policy capabilities. Okay, we are talking about fantastic ways to understand what are the innovation capabilities in our country. However, the trick is that even thinking in such a complex terms is could be too difficult for a certain level of policy maturity, let's say. The officials may be, or the, let's say, policy making process may be not tailored enough. How can you explain for a minister that he might support other types of firms than aiming at import substitution, that we need to support firms which are kind of more focusing on complementary product process innovation strategies? I mean, it is hard. It is hard to design. It's hard even to express, but it's hard to design, and it's hard to implement and evaluate. So this sort of questions actually has to be somehow reflected in the policy recommendations, that actually the policy, we have to have a more sophisticated underpinning dictionary under this policy mix concept and similar framework, let's say, facilities that we are relying on. Okay, I stop at this point. Thank you so much.
So, thanks a lot, Vitaly. I think it was quite substantial, as all the other speeches we had today. Let me ask you, anybody wishes to give an urgent comment, remark?
May I make an urgent remark on Vitalis? The very last thing that he mentioned, actually, it sounded like my biggest surprise last year in Beijing, where I spent some time right in Beijing, and I found out there that in that government in China, the highest level of political management, the very highest, go to S&T policy training regularly. So universities, Tsinghua in particular, is training the highest elite, the top elite of decision-making elite of the country on issues related to science, technology, and innovation. That's it. I don't know any other country that, I do not know. Maybe other East Asian countries do this, but I do not know of any other country that does this. And this is exactly speaks to what Vitaly was talking about, and I completely agree with it. It's getting harder and harder show to policy decision makers what we are talking about. Most of them still speak the linear model of innovation language, most of them.
Nick, I have to remind you about Korea, that they hired JD to help them instead of going to the courses.
Yeah, there's certainly somewhat an interaction between the different spheres, but advisory role is one thing, training is a different story. So it might be an issue for further exploration, and I believe the right people to address with such a question, to give us a full picture, full overview, is probably OECD people. Why not? We might propose it for a research project over the next years with some more hard facts. UNESCO, similar institution who's doing such things in Latin America especially, but it's always a question of quality of training. That is for sure. So what you see on many cases is very likely that is something like a little bit consultancy, a little bit very basics, but nothing substantial. And if you just hire any trainer, whoever it is, forget it. You will have a negative impact. That is quite obvious. So as you know me, I'm sometimes pretty critical. I should not continue being so critical, since I see this session is being recorded and I have no idea what happens with the recording. So let me be very positive and praise the existing training measures, and especially praise the improvement potentials which the existing training measures and the existing staff for such training events provides. This is the positive diplomatic way. I would say thanks for all who gave their wonderful, nice speeches. Thanks for all giving us an idea, the insights for the upgrading and combined, complemented with conceptual thoughts about, well, if you call it benchmarking, comparative analysis, I wouldn't care about that here. But for new instrumental approaches and conceptual thoughts, improving all these measurement things, including international collaboration, which is a crucial issue, as we know, but the way we measure it now, it clearly leads to the wrong implications which appear then in the policy, since policy makers in many cases are not capable of understanding the indicators anymore at full, which are being prepared and provided. So that was my attempt summarizing our workshop today, which lasted for 3.5 hours in 3 sentences. So thank you very much. I wish you all a wonderful afternoon, evening, depending on where you are for the time being. Have a nice party, celebrate for given occasion, and I'm sure next time Boosing, definitely that comes as soon as we have Sputnik 5 or whatever it is, helping us to overcome any kind of travel restrictions. Enjoy the weekend and bye. Thank you. So.